Hi friends, this is the second video of Heliocentrism web series, Science Behind the Scene. Now, we are unraveling the biggest revolution of science, heliocentrism. And in the first episode, we started our journey from revolution from geocentric to the heliocentric. Now, we are going to learn in this video about the science behind the scene. What is the governing laws which are working behind that? So, just to quick a recap, this journey started some 2000 years before, where the Ptolemy gave the geocentric model that Earth is at the center of the solar system and all the planets are revolving around it. This theory was accepted for 1500 years, and then around 1510, Copernicus came up with an idea that it is not the Earth which is at the center of our solar system, but it is the sun which is at the center of the solar system. He called this as a heliocentric model, but because of the lack of evidence, it was right away rejected. So Galileo then around 1600 started collecting the evidence for this, and he was successful in collecting some sort of evidence, but church didn't like this thought process, so he was under house arrest throughout his life and finally died in 1642 around. Then one more scientist, Tycho Brahe, around 1610, in order to collect this experimental evidence, he catalogued more than 1000 stars data, but he couldn't synthesize those data and understand what that tells. So he hired one assistant, John Kepler, and John Kepler synthesized all the data and proved finally that yes, heliocentric model is correct. So it is not just a one day, 1 month or 1 year. It took 1600 years just to prove that heliocentrism exists. But Kepler couldn't answer one key question, that why all the planets revolve around the sun. He told us that yes, all the planets revolve around the sun, but why? What's the reason behind that? Kepler couldn't answer that. So now seeds of this why got implanted by our great scientist Sir Isaac Newton around 1665. Now this was the time frame when there was a major epidemic in the England, plague. This is called the Great Plague of London. Many people were dying. Okay, so not everything was getting locked down. School, university, colleges. Newton was also studying in the Cambridge University, but because of this outbreak, the Cambridge University also got closed and Newton had to work from home. It was not so much effective, so Newton took it as a challenge. This was the 2 years of time frame when the Newton lockdown created wonders. Let's understand what the Newton did while we all are suffering from this lockdown, how Newton utilized these lockdown periods. He realized that learning starts from you. It is not just a lockdown who can stop you from learning. So from his home itself, he started seeing the planets' positions. He also did a multiple experiment to understand the Tycho Brahe data, the Kepler laws. He also did a lot of experiment on the light through prism and spectrum. Many times experiment worked, but many times didn't work. Okay, but he never lost a hope. And finally, after so much of work, around 1687, he published his most accomplished work, the Principia, also called Mathematical Principle of Natural Philosophy. This is not a book. This is basically the governing laws in the nature, how the nature works. These are the governing laws. It took 2 years just to write these governing laws of nature, but this was the thought process of past 20 years. In this book Principia, he gave out the 3 main points. The first one, the laws of motion, how the nature moves, what are the governing laws behind them. The universal law of gravity, And finally, the theory of calculus. He told that there is a new branch of mathematics need to be developed to understand the nature. He called this as calculus. Now let's demystify this in a little bit more. So these three laws of motion, they are the revolutionary models or the laws of nature. Newton was the first person to realize that. So if we see they looks complicated initially, oh my god, what are those? But let's understand what is the basic intent behind them. These laws tells us why the few things move in our nature and few not. If you see, the trees are standing, they don't move from one location to another location. But birds can move. Question is why? They are the organisms. Why one organism can move, one organism cannot move? What is so different? Nature is not partial. What is the governing laws behind them? So, let's understand these three laws in some little detail. The first law, what the first law tells us? It tells us that every object in this universe possesses some sort of a stubbornness to change. They don't want to change. If somebody tells you that you need to wake up early in the morning, you will show some sort of a resistance. No, I can't wake up. That's my sleep time. So that is the resistance to change, stubbornness you are showing. Similarly, if you tell to a child that it's a lockdown, you cannot go outside, you have to sit for a year at home, what will be the expression? No, I will not do that. No, I will not do that. So we know that all the living things actually show some sort of a stubbornness. Some has more, some has less. But what the Newton realized, that it is not only the living things, it is the non-living things also shows stubbornness. That means this log of wood also shows some sort of a stubbornness when you try to move it. Oh my god, that is a new concept. Yes. And that's what the Newton realized, that every single object in this universe, whether it is a living thing, non-living thing, shows resistance to change, stubbornness. And he told this word is inertia. So basically what is this inertia is? Inertia is nothing but if any body is in at rest or in motion, it will show some stubbornness to change in a state of motion. Then he told, if you want to overcome, you need to apply some force. So, in order to overcome that stubbornness, you need to apply the force. So, force is responsible to change that stubbornness. Okay. So, now the next question comes, what is this force will be? And that's the Newton's second law. So, force required to overcome this stubbornness. Suppose you want to move from one location to another location, you need to apply the force, but how much? Which was given by second law. So F is equal to ma, mass times acceleration, is the force. So it is the quantification of that force needed to move, needed to stop, needed to overcome your stubbornness. Based on this law, there are many things around us are working. One of them is rocket, we know, your aeroplane, your vehicle. All these things works based on the second law of Newton. And the last law, which is the most important law, we call the third law. What the Newton told, in the nature you cannot apply a single force, it is not possible. Only you can apply the force in a pairs, in the two quantities. Those two forces are equal and opposite in direction all the time. Just take an example. This is the balloon in which this is open, the gases are coming out. So they are applying the force, okay, on the air. So air also apply the force upward. That's why the balloon goes up when you open like this, when the air is coming out. This is based on the Newton third law. Now these three laws, they are not just a law. They are the giant leap forward in the scientific thought. During that time also and during this time also, based on this, there are so many things around us are actually designed. These laws told us how the nature is working, why the things are moving, why are not, and how we can move if we want. Now, utilizing this thought process, we can actually answer this question, why all planets revolve around the sun. So Newton told it is the force. Basically, he called force of gravity of the sun, which is binding all these planets around the sun. He told this force of gravity is so huge and it is applied by the sun on the earth and on all the planets. So all planets revolve around it in the elliptical orbit or in the oval shape. It is so huge force. Amazing. And then he actually quantified. He told this is the universal law of gravity, and he quantified this by this formula. It depends upon the mass of the two objects and the distance between those two objects. Gmm upon r square. We have learned this in our school time. Again, why all planets revolve around sun? Because of the force of sun gravity, because of the pull of sun. But the next question comes, how much this force will be? Is this force sufficient enough to move so much? What do you think? Stay tuned for more learning. Thank you.